let's do, let's try sulfate. SO4.
-2.
Yeah. -2. All right, so first step's counting valence electrons. Sulfur gives us 6 according to a group number. Oxygen also gives us 6. And then that -2 tells us we need to do what? Add 2 more electrons to it because we've got 2 extra electrons. Yeah, so again, we're at 32.
So is it going to look the same?
It's going to look similar. There's going to be one thing that's different.
Sulfur.
Oh, because sulfur is...
Don't spoil it.
Oh, sorry.
Come on. I'm not there yet.
All right, so there's our skeleton. We're going to bond 2, 4, 6, 8. So our rule is to fill the outer electrons first. All right, but if we do this, do you see a problem? Right, we said oxygen contributes 6, but right now it has 7 close to it. So right now, all of my oxygens have negative charges attached to them. And what charge does sulfur have attached to it?
+2.
+2, okay? Because sulfur contributes 6, but it only has 4 here surrounding it. So it's got a +2 charge. So this is problematic that all of our atoms have charges. So what's the solution to that?
2 oxygen.
We're going to double bond oxygen 2 times,
Wait.
okay? 2 different oxygens are going to double bond.
But wouldn't, so there's 4 negative charges on the oxygen and +2 on the
That's
sulfur.
right. It does.
So it cancels out.
That's right. It adds up to this charge for sure. But it's still, all of our atoms are uncomfortable. When we fix this problem, if we double bond here, let's say we get rid of this, double bond here. And let's say we do the same thing on the other side. We still have a -2 charge,
Oh,
right? But we
yes.
got rid of formal charges for 3 of our atoms. So that's more comfortable for those, okay?
Resonance will then-
You would still need 4 resonance because you'd go opposite, opposite, and then side by side, side by side.
So do you need 4 resonance for every single one?
No, not everyone. Ones that have 4 things on the outside, maybe, right? But we're going to look at a different one here in a second that we won't need 4 with it. But if we were going to draw resonance, we would draw all the versions of that. But right now, we just don't need to necessarily. Okay, the goal is to have the formal charges add up to our formal charge of our molecule, right? That's the whole point. We got to see that formal charge come to life. Let's try nitrate. NO3 -1. Nitrate is NO3 -1.
Did Chem 1 just finish doing the instruction?
That's right. So I've used all 24. What problem am I running into? 2, 4. Am I supposed to have 24? Did I count that right?
Yeah, I got
Is that what you have? So I've used all 24, but right now I've got negative, negative, negative. Positive 2.
Can you not add a lone pair on top of nitrogen?
Where would it come from? Because I think we've used all of our electrons, right? So what option do we have?
Double bond.
Double bond. Can we do it on both oxygens? Can we do it to 2 oxygens? No.
Why would you have a lone pair on
I don't think I have enough electrons to do that. Right? I've used all 24 right here. So if I don't do that, if I would move one of these to a lone pair, nitrogen's good, but then oxygen has an incomplete octet. So what we're going to do is let's double bond, okay, and that removes oxygen's formal charge. But here's the deal. Nitrogen is not allowed an expanded octet. Okay, phosphorus was allowed an expanded octet because it was in the third level. And that's when d orbitals become available. Right? Before that, molecules in the second energy level, carbon, nitrogen, oxygen, fluorine, none of those are allowed an expanded octet because there's no 2d orbitals. Right? There's not space for that. So here's we have to stop here. And nitrogen still has a formal charge of +1. Right? That would mean that we canceled, two of those. Cancel that one, cancel that one. We still have a resulting -1 charge, but we don't eliminate the formal charge of nitrogen in this example.
How did we cancel?
Just mean to get the resulting -1, we canceled it with the positive from nitrogen. Right? If you've got 2 negative charges and 1 positive charge, that gives me a result of -1.
Oh, yeah.
That's all right. It's still present. I'm just saying to get the molecule's charge, we've got an overall -1. And so how many resonance structures would you need here total?
3.
3 total. This one and 2 more. Right. All right, very good. Let's try one here. I don't know. Let's just try another one. Let's do C2O4 minus 2. Do you know what that one's called? I don't know if we actually memorized this one.
Oxford.
It's called oxalate.
Ooh.
Oxalate. I don't know if we did that one.
No.
No. Okay.
I know it come across as some.
All right. So let's add up our valence electrons. Carbon each gives us 4. Oxygen gives us 6 each. We're going to add that to, let's see, 24 plus 10. I think 34.
Mm-hmm.
Okay. We've got multiple central atoms here. So how does that work?
Each one gets 2 of the oxygen.
That's right. Yeah, we just put them both in the middle and we spread the oxygens out evenly.
Mm-hmm.
Okay. 2, 4, 6, 8, 10 I've used. So I've got 24 left to put on, which I think you should see is going to go evenly, right? 6 per oxygen. Okay, but what's the issue if we stop there? I've used all my electrons. I don't have any extra.
Carbon wants 4 bonds.
Carbon doesn't a full octet.
That's right. Neither carbon has a full octet, so how can we fix that?
Double bond carbon.
Double bond carbons together.
But then your oxygen loses an octet.
Mm-hmm.
So
So what can we do?
double bond
Oxygen.
one.
2.
Okay, so we do this. Double bond here. That fixes this carbon.
On each side.
Yeah, I need to do it on both sides.
And then you have to have like
Oops.
4 resonance.
Yeah, you would have to have 4 resonance. Okay, your resonance would be here, double bond. There, double bond, and then both top, both bottom. We wouldn't have a resonance structure where we have double bonds on both sides, would we?
Mm-mm.
No, that wouldn't work, right? Because that would give this carbon too many and this carbon not enough. Okay, so just be thinking of that. You don't have to draw the resonance right now, but that's a good example. And then we would make sure we put the arrows and we put the brackets. Which of my oxygens here have formal charges on them?
Top right, bottom left.
Yep, top right, bottom left. Okay, so an oxygen with a single bond usually is going to carry that negative charge.